All right, so welcome everybody. I have the distinct honor of the last session of the day, which means I try to make it short. But hopefully you can get some value out of it, even if we rush a bit. If you have questions, I'd love to take them, but please keep them to the end so we can try to stay on time and make up for some of the time we've lost. Yeah, as said, my name is Michael. I'm a solutions architect at Amazon Web Services, working with customers in the German market. Let's say larger, mid-sized customers and mostly enterprises. And I'm coming from a background that's mostly focused on data science, on building infrastructure for handling big data problems. So I'm definitely coming from that side of the house. And that's what I'm going to focus on in this talk. Whereas the previous talk really focused on the how do I get data out of a device. I'm going to focus on what do you do with it once you actually have the data. Talking a bit about IoT and cloud, you've seen many booths outside where cloud computing is a consideration. Like I've said, two parts, like when talking about IoT and cloud, getting data in, communication, fleet management, SIM card management, of course. But then, of course, once the data is in cloud, how do you actually drive innovation? How do you generate value out of that data? What the end customers are typically asking for is a way of monitoring and alerting, so device management, reacting on changes and differences. But also, the general ask is to have like a flexible processing option, right? So once they have the data in the cloud, they want to have multiple options for how to massage the data, how to mangle that data, and actually analyze it. From real-time like questions, dashboards, and so on, real-time reactions to things that are happening with your devices, to your devices, down to a longer-term focus on trends going over months, years, and decades even. And more, the ask is to actually predict and recognize issues before they appear, right? So really, the whole field of predictive maintenance, that's a big area of research and a big part of the field where the value comes from. And people want to control the devices, of course. All of that in real time, near real time, and at scale, right? From small deployments up to millions of devices. What customers are achieving is they do mid and long-term analysis. They have their teams of data scientists or whatever you call them working with that data, doing like interactive, explorative analyses. They want to provide real-time views, dashboards, KPIs for their business partners and themselves. And they want to talk to their customers, right? When something happens, notify their end customers that something did happen, what happened, where, and so on. And of course, they want to create services that build on those devices and all the data that they generate. Wrap those services in APIs, thus drive value by reselling the APIs, reselling the lessons learned from the data. And again, everything in real time and at scale, which doesn't make it easy. Quick show of hands who's heard of Amazon Web Services before? Okay, number of folks. I'm going to make this quick. Amazon Web Services is arguably the largest cloud computing provider out there. We've been doing this business since 2006. Kept adding more and more services, kept adding more and more footprint. And why we've been doing this is that we believe that there's a lot of benefits to gain from leveraging cloud computing. First of all, you just pay for that amount of infrastructure you actually use, right? We can provide a low cost of actually running IT just because of the massive amounts of processing power, for example, if we have the storage space, which affords us a lot of economies of scale, which we can then pass on to our customers. And we take care of all the capacity management, right? So you can just get capacity when you need it and only then start paying for it. And if you're done with your project, with your analysis, give it back again. The first three items combined basically mean that it's very straightforward and risk-free to run experiments, right? Because if you have an idea you want to try out, you can get the hardware, so to speak, immediately. You can start using it. If that turns out to be bigger, get more hardware initially. You pay while you use it, but if the experiment doesn't work out, just stop everything and you stop paying. And that makes experiments like very pain-free. But overall, the main benefit of cloud computing is that you can really spend more time on your business, on the key things that make your business, which typically doesn't involve IT and running data centers. That's really what we're good at, what we've done for the past 10 years on a massive scale. AWS, or Amazon Web Services, has a global infrastructure. We operate dozens of data centers, split into 11 so-called regions. Every region is basically a cloud of its own. They're segregated, except for the account management. So you can have one account that allows you to deploy workload, for example, on the US West Coast, in Sydney, Australia, and so on. But you really pick like which cloud you want to use, or if you want to use all of them. But you decide like where you place your data, where you place your infrastructure, and how you connect to those different regions. Inside every region, there's a couple of so-called availability zones, which again are cluster of data centers, structured in a way that they don't share the same risk profile. So for example, they don't share the same ISPs, they don't share the same electricity grids, and so on. So you really can build like highly available and fully redundant systems even within one of those regions. And AWS provides a massive number of services. So current count is more than 40 different services. Of course, the bottom layer of infrastructure services, that's what most cloud computing providers offer, right? Most offer compute, storage, and databases. AWS has kept adding layers and layers on top of that, like cross-cutting layers, like a whole security management suite of services that handle encryption, that handle auditing, that handle authorization, authentication, VPN connections, monitoring, et cetera, but also platform services, which you can really incorporate into your application, into your devices even, to handle certain aspects, such as analytics, for example, that offer like services for mobile developers and so on. Today, we're not going to talk about all of these, obviously. We're going to focus on a key few, the ones that are focused on building analytic applications and some of the key infrastructure services, which are probably the most well-known or the most easy to understand services. And it's important to point out that AWS keeps iterating very quickly. So we keep adding features pretty much on a daily basis. And that's one of the things that sets us apart, right? We have a lot of operational experience running dozens of data centers, I should say really large data centers for the past 9 years or so. A lot of breadth in terms of the services that we offer, the features that we offer in those services. And we're very customer focused. So we typically launch like one new feature every half a day or so. So it's a really high pace, and that's all driven by customer demand. And all of that on a global footprint, which is especially important when you talk about like big IoT deployments, for example, where you really want to make sure that your infrastructure is close to where the users and where your devices are, right? So that's one of the key areas. I mentioned low cost. Part of our philosophy is that we build out massive economies of scale. We really cut costs where we can, and then basically pass on those cost advantages to our customers. So we've proactively reduced our prices almost 50 times so far. And we have a big ecosystem of partners, implementation partners, software partners, and so on. I'm getting ahead of myself, I guess. Very quick look at some of the initiatives that we see in the IoT field. Hello? No, doesn't want me to talk about it. Come on. Oh, whatever. I'll talk about the customer examples briefly. So obviously there's some examples within Amazon. The whole robotics field, devices that we have, even like drone delivery, which you might have read about. All of these are like internal projects that run outside of AWS, but within the larger Amazon company. But we have many different customers that run IoT initiatives. So for example, we have GE, which does a lot in terms of predictive maintenance, a lot of collecting data from things like turbines, engines, of all sorts. We have projects with a number of automotive companies, for example, about connected cars, about fleet management. Tata Trucks is one example. We're also working with OEMs across Europe and Japan as well. One example I really like is like the Philips City Touch project, which is one of the few references I actually can talk about, that basically allows you to build like a remote-controlled grid of streetlights, right? And they have deployments in Rotterdam, for example, and all over Los Angeles, which are currently building out, which means they have like lots of smart light fixtures, right, deployed all across the city. That obviously helps cut costs, reduce maintenance efforts, and so on, but also provides new services which they can then resell to the city council and whoever is operating that. For example, to change the lighting mood, for example, depending on time of day, on the kind of events that are happening in a certain street. They can really control the lighting down to an individual street or a lamp post somewhere. That's a really cool project, which I actually like. In the interest of time, let's have a quick look at big data in the cloud. I was talking about big data because that's part of where I'm coming from. It's also one area where the cloud can add real value because handling big data projects on your own, like on premises, with your own hardware and so on, is really challenging. But it's a very good mix, very good match for the cloud, actually. Why? Because big data problems typically have a couple of problematic angles. Either it's like the variety of data that's coming in, so it doesn't fit neatly into a SQL database, a relational database, or it's just the sheer volume of data that you need to ingest, that you need to process, or the high velocity that data comes rushing in, right? And in the cloud, we can offer a multitude of different services, different storage and compute options that allow you to tackle those individual problems without having to invest into building separate technology stacks of your own to tackle these different things. And the cloud provides a lot of capacity to handle those massive data sets. And as I've said before, it really allows for easy experimentation. It's really easy to spin up clusters of machines to run like a distributed analysis job of a certain amount of data. And if you have like 10 people who are interested in the data, you can run 10 clusters in parallel if you like, right? And shut them down once you're done. The bad news, though, is that there's not one tool that solves all your big data needs, right? And that's why we've basically built a lot of different services. I won't have time to go through all of them, but these are like our main service offerings in the big data space. They all have their pros and cons. Each of them has its own like reason for being. S3 is probably the most well-known. It's one of our oldest services. It's really like an object store. It's just a platform that provides massive durability. So basically everything you store there would not get lost. It provides high transaction rate, and it's like really scalable, right? So you can place any kind of objects between 0 bytes and 5 terabytes in size in there, and you can have as many of those objects as you like. If you store 5, if you store 5 billion, if you store 5 trillion, that's entirely up to you. You can just scale up and down as needed. You just pay per gigabyte per month in terms of the data that you've consumed. And that makes it a good fit for just ingesting massive amounts of data, like in batches. If your data is more like trickling in, or if you have a stream of data rushing in, Amazon Kinesis is a good service because that allows for real-time processing, even at high throughput, right? It can support up to 100 or more terabytes of data coming in per hour for ingestion, but you can also start with a trickle stream of like, I don't know, 1, 2 transactions per second. It's very easy to set up. It's fully managed, and it integrates with some of the other services that we have with Hadoop and so on. If you're more like looking for databases, you want to keep track of counters, for example, we offer a fully managed NoSQL database that's also fully managed and entirely scalable. And by fully managed, I mean you literally just define a table name and you tell us how many writes per second, how many read requests per second you want this table to sustain. Whether that's like 5 per second or 500,000 per second, it's entirely up to you. You can dial it up and down as you go. That doesn't have a lot of query capabilities. If you need like rich queries, we have like a data warehouse service. Again, fully managed, but with a SQL interface, right? Scales up to petabytes. I won't go into a lot of details, but it's a very compelling offering if so far you've shied away from data warehousing just because of the complexity and cost involved. Because this is like a fraction of the cost of other commercial offerings, including everything. And as it's fully managed, it also allows you to grow your cluster, for example, as more data keeps coming in. So you can start small with like a single machine or 2 and grow up to hundreds. We have Hadoop or Apache Spark as a managed service, so you can like provision clusters from one machine to thousands of machines within a couple of minutes. We'll take care of all the installation. We keep the cluster running. We help you with provisioning of the tools. You can just select which kind of tools you want, whether that's Apache Spark, HBase, Hive, Impala, whatever. And it's very tightly integrated with other services. It has a very high-performing integration with like Amazon S3, which I've talked about, DynamoDB, and Kinesis. So whether you have like big data lakes or databases or streams of data coming in, you can all process them using MapReduce. And if you want to move up the stack, we recently introduced machine learning as a service as well. Right? So that's also an interesting Addition, especially when you think about like predictive maintenance and those kind of problems where it's like really about like detecting patterns, right? And that's a very high-level service that's meant to target developers who are not necessarily data scientists or statistical experts. It provides a number of classification algorithms. It is a supervised learning model, so you basically need to provide training data. The system then builds a model based on our expertise, so it sets the right parameters, it allows you to tweak a little bit, and then you get a fully trained model which you can just run on your data. Right? You either pass in bits of data from a stream or just handle it like all the data you have at once. Let it make predictions. Let it classify the data into plausible, non-plausible. Is an error likely to happen? Is the device okay? Those sorts of problems you can run automatically without having to define rules of sorts. And all of these services fit into different ways of using big data, right? So you can do retrospective analysis and reporting. A couple of services fit into that niche. You can do like here and now processing, building dashboards and so on. That's mostly the domain of Kinesis. Or you can enable smart applications by leveraging our predictions API. Now, if we take those services and actually put them in an IoT context, basically, when you have a lot of things which you want to connect to the cloud, you need a couple of different layers. You need a layer focusing on what I've called device DevOps, right? So just managing certificates, managing devices, but also authorization auditing, so the whole device management layer. That's used like whenever something needs to change with a device. But the bulk of the work happens in what we've called the speed layer. That's basically the layer that processes all the telemetry data coming in from the devices and all the commands that are getting sent back. And if we want to look into like processing some of that telemetry data, we basically take that data into our serving layer, right? Where from there you can take it, process it, or just store it. Just archive the data for future reference, or compute real-time views on that data, or run analyses, run correlations, use using machine learning models to actually classify the data, and then generate decisions automatically, which can then be transferred back to the devices as commands. And there's a couple of different ways of how you can build this part, at least, of the system. So a good option is actually to start with Amazon Kinesis for just streaming data in, which supports HTTPS, which is not a great fit for many like very constrained devices. If you have a constrained device, what people typically use is some sort of MQTT or CoAP broker running in front of Kinesis that can be globally distributed and then basically just gets the data from the devices locally, assembles them regionally, globally even, and it creates like a unified stream of data, of a unique view of everything that happens in the world of your devices. And basically, when everything enters the stream, it can come from millions of devices, from dozens of devices, it's properly authorized and then it's stored durably for the duration of 24 hours in 3 different data centers. So it's always replicated. And then at the end, you get like an order stream, basically a rolling 24-hour window of all the events that have happened to your devices, in your devices. And you can connect this stream to like a multitude of different applications for different use cases, right? Again, coming back to the 3 different models that we have for processing data, if you are mostly interested in like retrospective reports, you can consume that stream and just push that into S3 and just build a data lake, right? It's massively scalable. Just dump everything in there. If it's like terabytes per hour, doesn't matter. You can just dump data in. Whenever you want to learn something about the data, whenever you run like a report, whenever you want to run an analysis of sorts, you can spin up a Hadoop cluster using Amazon Elastic MapReduce. Cluster will come up within minutes, can process your data, can generate insights, and feed those back. Or you can also access it directly using any of the third-party tools, right, that support JDBC, ODBC, or Hadoop directly. And even those tools are available in our software marketplace, right? So you can actually rent many of these on an hourly basis as well, right? Or if your data is like easier to handle, if it fits better into a relational model, just pump part of your stream into your data warehouse, right? And make that available for exploration, for example. But you can also do both at the same time. Both if you want to have like ETL, if you want to pre-aggregate your data, or if you have like if you have two needs, right? If you want to keep like a certain amount of data in your data warehouse for like immediate exploration by your teams, and you want to have like a data lake which stores everything in the event that it might become useful at some point. If you're interested in like processing data here and now, you can connect like so-called Kinesis-enabled applications that have like a certain library included, or use tools like Spark Streaming on top of EMR, or things like Apache Storm, which basically can consume the stream directly, process it, or all sorts of CEP platforms. I guess you could add more and more options here. Use the results coming out of that, store them in an intermediate database, could be a relational database or could be DynamoDB if you don't want to spend time managing that piece of infrastructure. Then have like automatically scaled groups of web servers actually running the front end, right? Especially useful if you have like a massive number of devices and millions of customers actually owning those who want to know what's going on with their device. There you have a use case where it's like really important to have like a scalable system on that right-hand side of the picture. And of course, if you want to make predictions, a similar model. You can just basically take a Kinesis-enabled app, take part of the data, pre-aggregate it, and then feed that into a machine learning model or more, several that you've built that will help you automatically classify that data. That basically have been trained on some of your prior data, which resides in your data warehouse, for example, in your data lake, to understand the patterns that are in that data, and then get predictions for the new data that's coming in. That's a very powerful use case, and it's actually fairly easy to build using these services, right? There's even ways to do that without running a single server, just hooking everything up. To conclude, I hope in the shortness of time I've managed to show you a couple things, especially why the cloud is a good place for device data, right? Mostly because of ease of use and scalability, but also because of the global availability, which really helps with like large deployments. And it's a lot more efficient than running things in-house because of the cost efficiency and the scalability effects, right? You can scale up and down as needed. If you think about connected cars, for example, it's no secret what cars do most of the time, they park. They don't generate any data, right? And if you have like a scalable infrastructure that really only listens in and stores and processes when a car is actually moving and when all the cars are moving at rush hour, which can handle that stream of data and then resize itself down, like during off-peak hours, that can really make a big dent in your cost calculation. It can really save you money. There's a number of services that can help you modify your data, analyze your data, and I hope I've gave you a quick idea of how you can combine some of those building blocks. Some of our building blocks, some commercial components, some open source components into like architectures that really help to leverage the data that you already have once you've loaded it into the cloud and generating value out of that data. With that, thank you very much. If you have questions, I'll stay here. So just grab me, and otherwise send me email. Thank you.